Welcome, ladies and gentlemen, friends of the Jörn channel. Michael Schiebel, the man behind the camera, and myself, my name is Reinke. I welcome you again to part 2 of our development video, which is the first topic in our new format, talking about Jörn's secrets. Okay. As I've mentioned before, I've talked too much about development, so we split the video into 2, and now we have part 2, so please enjoy. But I recommend to watch this video up to the end, because then you find some nice, let's say, challenge for you. Okay, keep patient and enjoy the video, and don't forget to subscribe. So, when we have the first prototypes, we check the dimensions, we check the stiffness, we check the pretension force and the closing forces of the housing. How does that work? I want to refer to the video we've made about how to install a slit bush, how to install a dual bush. That's in our YouTube channel. You can find that very easily. Please look at that again. I mean, you can always learn from these videos. And another thing is that we check the bonding quality, the bonding between the rubber and the metal. So therefore, we just destroy by tearing the parts to get information about the picture, the characteristic of the crack, as well as the forces you needed to get it separate. And then it continues depending on the agreement we have. Either we just send the parts to you for you to test, or we test the parts in our house at our Hydroponics testing machines. Of course, both is also possible. Talking about Hydroponics testing. As you have seen in our other videos, we have a Hydroponics test bench. We have 6 independent cylinders, which could be grouped in order to get a multi-actual load applied to the parts. We can do a so-called one-step Zenos load, so which means one load level, one frequency, and it's operated until the part will fail. We can create a block program, or of course we can apply real measured load data. However, real load data to be tested will take a very long time, because there are many load events included which are on a rather low level but at a high number. And if they don't contribute to the crack behavior, I mean, it doesn't make sense to get all these things tested. There are methodologies, you may have heard about that, and most likely you apply those as well. There are methodologies to shorten, to concentrate the lifetime testing by, let's say, increasing the amplitude level, but lowering the number of load events. However, if you want to do so, you need to know very detailed the behavior of the part in terms of what does the stress number curve really looks like. I mean, I'm not talking about where it's exactly in the field. It's more the incline of the curve. That's more important for that, to get a load equivalent new load spectrum. And the stress number curve of a rubber metal part depends on the pretension which is applied to the part due to assembly. So that's individual part by part, and you can't take a standard number for it. So what you have to do, you would first have to get an idea. You have to evaluate the stress number curve, and then you could create a load equivalent new load spectrum. That is very complicated. Another issue is, by increasing the amplitude of the test at the same frequency, you also increase the deformation's velocity, and that applies more heat to the part itself, and the characteristic or the behavior of the rubber metal part will change at different temperatures. So it's not, so the load spectrum might be equivalent theoretically, but in reality you will get another kind of crack. So at the end of the day you can't really do it. Another way of shortening, of roughening the of concentrating the load spectra is just by increasing the test frequency. But that also could lead to, or will lead for sure, will lead to higher temperature to the part. So it's also another way which can't be done. So what we recommend is that we will develop, with our experience, with our knowledge, based on the real measured load data spectra, we will create a block program. So at different load levels, different numbers of the load event, and this is then a new combined load spectrum, which is then pretty much equivalent to what you see in reality. So that's what we do. That's what we recommend to do. Of course, I've said already we can do the tests multi-actual, but as more access you get involved into the testing, as more complicated all these comparisons are going to be. Talking about temperature, of course, in many applications, such as if the part is near to the combustion engine, for example, if it's warm for whatever other reasons, you need to consider that as well in the fatigue behavior of your part. Therefore, we have built a chamber where you can apply heat or warm temperature to the part in order to simulate the higher ambient temperature. In most of the projects, and that's real, we achieve the property goals of our part with the first step of our layout. However, even though we have changes during the process, but that's most likely due to any changes anywhere else. For example, if we connect two components, to subcomponents by our rubber metal part, and you change somewhere else in the machine or in the vehicle, a mass, a weight, dimension or whatever, that has an influence to the moments of inertia of the system, and that has an impact to the vibrational behavior, and maybe we have to compensate these changes somewhere in our rubber metal part. We hope, of course, that we can adapt the behavior of our part by just changing the rubber hardness. That's the easiest ways. But sometimes, unfortunately, we have to change the tool. But that's how it is. Well, sooner or later, we will have, I hope sooner than later, we will have achieved all the goals, all the technical goals, and you're happy with the performance of the part. And that means that development itself, in reality, is done. Next step is making tools. Prototypes are done, prototypes are tested, prototypes make you happy. And it's all works. So we will build series tools. The series tools are pretty much the same compared to the prototype tools, beside the fact that you have a higher number of cavities of the tool, because you want to increase the productivity of the series tool compared to a prototype tool. And Sometimes if the number of parts you want to have is pretty low, we will just upgrade our prototype tool by including all the numbers and all the markings, and then the prototype tool will just harden and could operate as a small production tool that works. But again, if you need a higher volume later on in production, we need to build a more cavity tool. The process is similar. It's both injection. The machine type is similar. It's just normally a larger machine. But however, the tool itself is different, and therefore the characteristics must be proved again. So same as a prototype. So we do again the dimensional check. We measure all the stiffnesses in all directions, whatever you want. We do the bonding tests and these things. And of course, also durability tests are, depending on the agreement, are either duplicated at your site with in your vehicle, in your machine, wherever it's, all at our component test. That's a matter of discussion and agreement later on. But the likelihood that we fail at that stage is very, very low. It's very limited, of course. So if we get it done, the series tool is qualified as well, and then the initial sample process is going to start. Of course, we know that different customers have different requirements. Of course, we can fulfill all of those. That's just a matter of conversation up front. So we need to understand what your requirements for the initial samples are. And then we prepare the report, provide it, present it to you. You hopefully approve it. And then the development is really completely done. And the series production will start. That's it for development. We've closed 2 videos. Now about the development topic. Yeah, well, that's it. When I start talking about engineering, I can't stop. Please, I'm sorry, but I hope you liked it. And leave us a like, leave us a comment, share this video, and of course subscribe the channel, because you don't want to miss the next videos of this format, right? So thank you very much for watching us, and see you soon again. Thanks to Michael Schiebel as well for the kind support behind the camera again. Okay, bye-bye. So, the end is not the end. I have one further, let's call it, challenge for you. If you're an accurate observer of our video, you may have seen some mistakes in direction. So please let us know whether you found that. And I will consider a bonus for you. Okay? So I'm looking forward to your responses. Bye-bye.